Hey Sc8, welcome to your last lesson in Unit D on mechanical systems. We've actually covered some of this stuff already with the crash course video that had to do with the Industrial Revolution and also the tech of the Industrial Revolution video, but this is our chance to kind of go through the formal lesson and then get some notes for that. So let's get into it. It's a lot of odds and ends. This is a weird lesson. Anyways, topic 6 to 8. Here we go. First thing is such a minor point that's all about just vocabulary. Modern machines are complicated. When you look at something like a car nowadays or a phone or whatever, it's complicated. There's a lot of stuff going on. And many simple machines are often working together to carry out a function. So we call these very complicated machines, ready for this? Complex machines. Yeah, when we have a bunch of different simple machines and stuff working together, we call it a complex machine. That's the vocab. Now, within that complex machine, we have systems. Systems that do things and work together to perform a larger function. This might remind you of something. Remember systems in the human body when we talked about the cardiovascular system or the respiratory system or the excretory system? Same thing. We have a bunch of parts working together for a larger function. Now, within that system, we can also have smaller subsystems. So that just means a smaller system within a system. That's it. That's it. So when we talk about something like the steering system, when we look at a car, I mean the steering wheel and the parts involved in the steering wheel or the steering assembly could be called the subsystem. So that's all we're talking about here. You can almost think about a subsystem almost like an organ, right? When we were dealing with body systems. So from this slide, just understand the idea that when we have a complex machine, we call it a complex machine. And that complex machines are made out of larger systems that perform a large task. And then that can be made out of smaller subsystems. And even the subsystem could have and will have several simple machines within it. Okay, so that's that slide. Let's talk a little bit more about machines and technology and society. So as you learned in the videos, machines help people use energy more efficiently. The earliest machines were simple devices. They weren't anything crazy, but they just made work easier. Maybe a lever in order to lift something, or this beautiful water wheel-ish thing, which, you know, would be a wheel and axle and inclined planes and all that, which could be used for irrigation, right, in order to get water from one spot to another. But these simple machines relied on people or animals as their source of energy. So people or animals were providing the force in order to make things turn, which means that there were some issues, right? Because we can only exert so much force without having a lot of people or a lot of animals. So that's where machines that got increasingly complex were used to satisfy basic human needs and got better and better and better, leading up to things like the steam engine and the internal combustion engine to make work much easier than you could with animal or human power. Different modes of transportation have changed as science and technology have developed. Newsflash. Examples: canoe versus motorboat. Motorboats go a lot faster and they're easier because you don't have any of that pesky paddling. Dog sled versus skidoo. You don't need the dogs anymore because you got the engine and the skidoo. Yay! Horse and cart versus sports car. So, I mean, you get the trends, right? It's changed. Transportation has changed as a result of machinery. So let's talk a little bit about the history of engines. And we'll start out by talking about the steam engine. The steam engine, to begin with, wasn't actually about having that kind of circular motion that we think of. It actually was just built to bring water out of the ground for mining. So, you know, when you're mining, there would be a lot of water maybe collected on the bottom. You need to get that out, and that's where the steam engine would come in. It would provide a way in order to get water removed through suction from a deep hole. So What would happen essentially, and this is talking about Savory's engine, okay, Thomas Savory, which developed the first practical steam engine in 1699. So essentially what happened is that water would get heated up, right, become steam. It would go through the steam valve, and then it would go into this chamber here. At that point, the steam valve would be closed. The steam would cool, as steam does when it's no longer being heated, and it would condense, making a vacuum. So leaving a bunch of space where we don't have any particles, low pressure. And as a result, that pulls water up through here. These are one-way valves, right? So, I don't know how to explain it, almost like a bubble valve where things can go through one way, but they can't slip back down. Almost like you have in your arms and your veins and all throughout your body in your veins. It has these valves that only allow movement in one direction. So when the pressure goes down in this compartment, it pulls water up, right? The valve closes, and then eventually it's able to get rid of the water, because once this valve is opened again, it pushes this water back down as steam enters with the high pressure, and the only way it has to go is up through here. Okay, so it can't go back down because of the one-way valve, so it's forced to then go up through the delivery pipe. So when the steam valve is closed, it's sucking up water into this compartment as the steam cools, and then as you open the valve again here to allow steam back in, it pushes the water from this compartment or chamber all the way out to the delivery pipe. So I mean, it's ingenious, it's neat, but horribly inefficient, and only for one specific purpose, which was getting water out of pits or mines or whatever is filled with water that you need to get water out of to make things a little bit easier. Now, of course, the steam engine was being fueled by something like coal or wood or something that burns to heat the water in the boiler, which would make the engine run. So no matter what steam engine, that was how it worked, is you would have, you know, coal or wood or whatever that would actually then be provide the chemical energy that then when you burn it would turn into thermal energy, which then would build up pressure as you make the steam. So you need the fuel, and that became kind of, you know, a bit of a problem as time went on, as you can imagine, because of the amount of pollution that took place and the high amount of carbon levels that occurred in the atmosphere and really jumped up during the Industrial Revolution and continues to increase to today. Anyways, as we've already talked about, the invention of the steam engine led to innovations in transportation, as we all know. So the first really useful steam engine, as you learned about in the video, was refined by James Watt. So he came up with this idea based on what he had seen on different steam engines and kind of going forward of coming up with a way to make a steam engine that then caused this circular motion. And the big thing that you saw in the video was the crankshaft, the development of the crankshaft to turn up and down motion, right, to actually become circular motion. And I believe where we're seeing the crankshaft on this model is right up here in this area. I don't know if you can see that, but right here, I think that's what we're looking at for the actual crankshaft, which then as a result would cause movement of this wheel as time went on. It might actually even be over here with the wheel, I don't know. But anyways, there's a crankshaft there, and it's turning the up and down, back and forth motion into circular motion. And that circular motion becomes incredibly useful when it comes to factories and looms and movement and transportation. And oh my goodness, the whole world opens up once you have this circular motion. Now, also over time, as trying to refine the steam engine, it actually ended up in developing the internal combustion engine. So this is just, instead of using the fuel to heat up water to make steam for high pressure, let's just actually like burn the fuel and use the pressure from the gases produced from burning the fuel as the pressure instead of steam. And that's what happened with the internal combustion engine. So this used, you know, gasoline or diesel or whatever in order to power the engine. So essentially, this isn't a big focus on the chapter. I put this in here just to illustrate it, but let's talk about it. Essentially what happens here is this piston goes down, and you can see here that we have a crankshaft turning the up and down motion of the piston into circular motion, right? Neat. Anyways, this goes down, and then as that happens, we have fuel coming in. Then as the piston goes up from the normal motion it has, right when it gets to the very top, the fuel that's in here and now trapped by the one-way valve, right? This valve closes, trapping the fuel in here. The fuel that's now trapped gets lit up so that it burns, and all of a sudden it's making all this pressure because of the gases that are produced from the combustion, causing a huge force pushing this back down. And then as this moves back down and gets to the bottom, well, now the exhaust can escape, getting ready for more fuel to come in and air so the whole process can repeat. And that's essentially how an internal combustion works. It's just that the gas or fuel comes in, it squeezes, it lights up that fuel, that pushes the piston back down from all the gases that have been produced, and also heat causing expansion, right? So pushes it back down, and then the exhaust comes out, the gases that are no longer needed. Anyways, it's neat. Now there's problems with this, as I'm sure you already know. Science technology has done amazing things, but sometimes we have not thought fully about the consequences, or kind of left it as tomorrow's problem. So science technology have given us many different amazing machines that have made our daily tasks easier. The automobile caught on very quickly as an example, but the ideal machine soon demonstrated its greatest flaw, which is of course pollution that is increasing all the time. Pollution of the environment was a result of more and more fossil fuels being burned in larger vehicles. Improving machines brought lots of positives, but there were also some negative side effects like pollution. And what you're seeing here is what would be called photochemical smog, primarily from nitrogen oxides, okay, which come from automobiles primarily. That's a huge source of nitrogen oxides, and that's why we have that large amount of smog hanging over whatever city that is. What's interesting about vehicles over time is as they become more efficient. So when I'm talking about more efficient, I'm talking about that full-on percent efficiency formula, right? It's gotten higher and higher and higher over the years. And now gasoline engines are higher than 30% efficient, which is really efficient for burning stuff and getting energy out of it. But as engines, internal combustion engines have gotten more efficient, it hasn't gone into making vehicles more efficient necessarily, but instead giving them more power, making them more fun, making it so you can tow more stuff. Right? So at the end of the day, the amount of pollution coming out of the vehicle hasn't changed. They're just better vehicles. They're more efficient, but they have more power. So at the end of the day, they still produce as much pollution. Now that's changing over time. And as more and more government regulations increase to lower pollution, then the industry adapts and finds solutions and develops new technologies to combat rising pollution. But that's a whole discussion that we don't want to get into right now. The Industrial Revolution, as again you learned about in the videos, absolutely just transformed society. Simple machinery has replaced hand labor since 1700s. Water-driven spinning machines were used in 1769 and could do the work of 12 workers. But as you got away from having to need water to turn the wheel to make looms and stuff go for making fabrics and so on, as you got away from that, it got even better. And then you could run the factory all the time, even when the water isn't running past it. So as a result, this just resulted in tons of factory jobs and mass production. Soon small towns became industrialized cities, leading to social change. People flocked to the cities to get work in the factories. And there was a complete shift from rural living to urban living, right? So things moving from individual kind of small colonies and stuff in the country to being big urban centers around the factories and the industrialization of society. So a big change. A big part of it too is that farming, producing food got more efficient as machinery got better as well. So that allowed less people to produce more food and feed the people in the urban centers. The question of whether technology changes society or society changes technology is still a challenge today. Kind of trying to consider like, hey, chicken egg situation. Does society advance because technology advances, right? So technology comes first, then society adjusts, or is it that society creates a need for the technology and then the technology gets developed? It's a bit of both, honestly. I mean, I feel like whether it's still a challenge today, I mean, it's both, right? It's hand in hand. I feel like it's like the arms race between viruses and organisms that get viruses, or antibiotics and bacteria. There's always this evolution or adapting that's happening for both things that adapt and thrive together. And I feel like it's the same with technology and society. They come together. I don't think you really have one without the other. The automobile uses cheap fuel and therefore more vehicles are being used. With cities so large, people need a vehicle to travel from place to place. Or is the convenience of having a vehicle just society's reason to have larger cities? That's an interesting question, right? And I mean, Canada has some of the worst urban sprawl of anywhere. I mean, Calgary as a city is absolutely massive in terms of how much space it takes up. And I think is one of the worst cities for urban sprawl in the world, from my understanding. At least I heard that at some point. I could be wrong. Don't quote me on that. But it's bad. Yeah, so it's something to think about. Big philosophical question for today. What do you think it is? Is it that technology causes these kind of things like urban sprawl? It enables it to happen? Or do we have urban sprawl so we develop better technologies to deal with it? Yeah, probably both, right? Depends on the situation. Probably a little bit of column A, a little bit of column B. This might be what we would call a false dichotomy, which means I'm setting up a choice for you that isn't actually a choice, where you don't have to choose one or the other. It could be both, right? So false dichotomy. Okay, anyways, wow, I'm philosophical apparently today. Yeah, that's it. That's all. That's topic 6 to 8. That's a little bit of a mishmash of different topics. Not a lot of hard things in here for you to know. Just understanding the idea of a complex machine system, subsystem, getting into a little bit the idea of the steam engine, that it's powered by burning coal or wood, that it used to just be for pumping water out, but then as Watt came along, it turned into circular motion. And then that caused the Industrial Revolution and urbanization of society and all that kind of stuff. So yeah, and pollution bad. Okay, that's it for today. Have a good one.